Okay, this is just a video to show you how to generate XY scatter plot using the protein concentration data. Okay, I have some hypothetical data here. Okay, so they will look better than the experiment that we have, the actual data we collected during our experiment. Okay, all right. So this is just for demonstration. You can use your own data, but this is what we'll be using some hypothetical data for the lab exam. So we're doing exactly what we've done in terms of the graphing in the lab. Okay, so now I have the three different readings, absorbance at 595 nanometer. The X is the protein concentration. All right, so now I've put a chart here. So protein concentration. So now you want to average the absorbance. So once again, average is ABERAGE of the open bracket. So highlight the three data of the same concentration. Make sure you're doing only highlighting the three data of the same concentration and then hit enter. Okay. I've seen mistakes being made here. Student type, average, but then they ended up, typing, selecting the entire thing or selecting the wrong, or just selecting one extra column, and then your average data would be very funny if you do that. Okay, so all right, so don't do that. So make sure you check it too. Okay, make sure you check it. You're only averaging the three reading of the same concentration. All right, so now once you've done one, you can copy and paste the next one. Control C is copy, Control V is paste, and then or you move it to the lower right corner. When the arrow turns black like that, you can drag down. Okay, turn to the little small black cross. If you're on this, you don't want to when you're on this white thicker cross. Then when you're the side, this actually means moving the cell, and then when you go to the bottom right corner, when the arrow turns this little black cross, then you can hold it, click and hold it and drag down. Okay. Now let's calculate the standard deviation as well. Standard deviation is going to be incorporated into the error bars later on. So you hit the standard deviation. The command is again stdev.s. Please only use the sample standard deviation, stdev.s. Do not use stdev.p. Okay, so we want stdev.s. Open the bracket and just highlight the same three data of the same concentration. Okay, so these are three different repeat of the same reading. And then so you want to just highlight the concentration of the same reading, right? Of the same readings of the same concentration. So hit enter again. So now once you've done one, you can also drag to the rest, and then that would be our standard deviation. All right, now here it says calculate the, sorry, it shouldn't be population. Let me just fix it. It should be the sample standard deviation. Okay, so previously I made a mistake myself. Oh, this is clearly a sample. So calculate the sample deviation. All right, so now let's actually now plot the average of the absorbance versus XY of concentration with the XY scatter plot. All right, so I already have the concentration and average absorbance for you, so you can highlight those two columns. You don't have to include the heading, and then but Excel would tolerate the heading if you do. So now insert now go to make sure you're inserting XY scatter plot. You don't want the line chart, okay? Line chart is not what we want. We don't want, some people give me 2D line chart. 2D line chart will give me that, okay? We don't want 2D line chart. We want XY scatter plot, okay? We want XY scatter plot. So let's try it again. Do this one, XY scatter plot. All right. Now this one you do want a smooth curve, okay? Because we're going to do a smooth curve. You can do solid line maybe, but smooth curve actually will look the best on this. Show the data point too, okay? So, all right. So smooth curve with the data point. All right. So this is our graph. We'll make it a little bit bigger. All right. Now we're going to try to incorporate the standard deviation Y error bars, okay? To do that, okay, so we will activate the error bars. Okay, so you activate the error bars, click on this little black arrow next to the error bar. Okay, all right, now when you first activate the error bar, it looks very funny. Okay, it's got like a cross on each of the data. Okay, so go to more options. Okay, and then you can then fix the error bar. Now there are two things you need to fix the error bar. Okay, so now if you have a PC, that's like what I do, Max, you can find a corresponding command in different areas, but I don't have a Mac, so I don't know how to demonstrate with one, but PC is very simple. You want to fix the horizontal error bar first. So series X is the horizontal error bar. Now make sure you are at this graphical icon, okay? It could be default here, it could be here, but make sure you select on this graphical icon. Horizontal error bar, we don't want any. So we're going to change it to fixed value of 0. Okay, fixed value 0. That's what we want the horizontal error bars to be. Remember, the horizontal is actually the independent variable. There should not be any error bars on the independent variable on the x-axis. Okay. All right. So now we've done the horizontal error bar. So you still want to go back to the same error bar. Okay. Now you can fix the y error bars now. So you want to fix the y error bars. Y error bar, make sure you're on this icon again. This should say vertical error bar. For vertical error bar, the default should probably be standard error, standard deviation. We don't want that. You see it's kind of uniform, right? So you want to go to custom and then say specify value, okay? When you click specify value, a small window should pop up depending on where you put your graph. It could be on the left or right. Now make sure this is not obstructing the data you want to select, okay? You need to move it out of the way so that you can select the data range that you want to incorporate onto your graph. So let's click on this positive value, backspace a few times, delete whatever is on it, and select the range from the go and select. But in this case, it will be I7 down to I15, the vertical range, okay? And I'll do the same thing to the negative, okay? Select the standard deviation that we have calculated. So this range here, we've calculated. Now you hit OK. Now you see that the protein concentration, the standard deviation that we've calculated is now incorporated as the error bars, okay, onto this chart, okay. All right, so fix a couple things. So also now change the axis title, activate the axis title, and change the title to something catchy, okay. So this is protein concentration, okay, versus sorry, this is absorbance. Okay, so absorbance at 595 nanometer versus protein concentration. Okay, so right, or you can say estimation of protein reacting with the Comasi blue reagent. Okay, give it a title. And now change the y-axis to the appropriate unit, name it with the appropriate unit. All right, so the y-axis is optical density, OD, at 595 nanometer, okay? And then the x-axis here is actually protein concentration, okay? So protein concentration. All right, so there's a unit for that too, microgram per ml, okay? All right, so once you've done that, okay, so you can see here, you want to use this graph to estimate the concentration of the protein concentration of the unknown. So to do that, you can also average that, okay? So now average the concentration of the unknown, okay? These three, that's the concentration, the absorbance value of the unknown. So now it's about 0.686. So what we want to do is to find a way to read off use this curve that we've generated, and then you see 0.686. So about here to read off, to draw a transect line, and then read off the concentration from the graph, okay? All right, so now before you do that, I want you to fix a few things, okay? So before you do that, let's fix a few things. You see here, this is scale of 500 increment, okay? Which actually makes it kind of difficult for you to read it, okay? So I'm going to change the scale so that it will be only a less 200 instruments. So let's click on this horizontal axis here. All right, so if you click on the label, you go back to this graphical icon. It may be on a different icon, but you go back to this graphical icon. It will tell you minimum 0, maximum 2500, major unit, auto, minor unit 500, 500 for major, 100 or minor. So let's change the major unit to just 200 increment, okay? And so the maximum is now, it will usually change it to 2200. You can set it yourself. All right. And so that will actually give us a more continuous scale. You can use it to estimate your concentration more carefully. And as for the x-axis, you can click on, the y-axis, click on it, do the same thing. Instead of major 0.2, you can change it to 0.1 instrument. So that would help you read the graph a little bit better as well. Okay. All right, so that's what we want. Okay, so now once we've generated this graph, it looks quite decent. We've got a standard saturation curve kinetics. So I put down here, use copy and paste the graph onto PowerPoint slide and estimate by drawing the graph with a straight line function with PowerPoint. Okay, so now I'm going to copy that And then we will open a new PowerPoint slide. Just open a new blank presentation, and get rid of the title box first because it will definitely affect your. All right, get rid of the title box. Okay, get rid of this box here, and then you don't need that. All right, so now you want to copy this graph, so just right click it, copy, or just hit Control C. It will be copy, and then go to your go to the blank presentation that you just opened and hit Control V or right click to hit paste. Okay, and then that you want to paste this graph over here. Now maximize it, make it a little bit bigger. All right. Now, because we want to now use this PowerPoint graph to estimate the concentration unknown, we need to draw the transect line here. Okay. All right. So now I've averaged the unknown value 0.686. So here's what I'm gonna. If you go back to our PowerPoint graph, so you want to read off 0.686, which will be about here, I guess. Okay, 0.6, 0.686, let's call it 0.69, about here. Okay. So now you want to insert a straight line. Okay. Now, if this is already open, it's over here. If it's not open, you go to insert shapes to give you this straight line. Okay. So add a straight line here, 0.686. That's just about here. Okay. Draw a transect line. Okay. Draw a horizontal line. Now you want to draw a vertical line. So once again, insert shape. Okay. So now draw a vertical line from where your horizontal line transect the curve. And draw a vertical line down. Okay, make sure it's straight. All right, now you want to read off this reading for me. Let's call that, that's about 660. Okay, so, all right, so now you want to insert a little text box to describe what you've done here. So say, okay, estimated unknown protein concentration. Okay, equal approximately 660, okay, microgram per ml. Okay, so all right, so this is how we generate a graph, how we use the standards that we've generated to estimate the concentration of the unknown. Okay, and why not give it a different color so you can know what's going on? Okay, so that is the graph that you need, and that's the Excel file that you need. So save the file. All right, go to save it as, and then save it to where you can easily find it. And then please put your name in the file. Okay, please say when you save the file. Okay, so this is the unknown protein concentration estimation graph. Please put your name in the file when you save it so that when you upload it, I would know it's actually your work. Okay. All right. And now go back to your Excel file, save those two files as well. So we did both the protein concentration exercise. So this is the protein concentration estimation. This is the Excel sheet. Okay. So all right, save that. And then you also want to now we did the first experiment we did the enzyme kinetics. So we did the enzyme simulation lab, and also save that into a folder. We calculated the Km and Vmax. Okay, so that was the so save that too. Okay, save as. I saved it in a different folder. All right. All right. We'll go to 206. This is the enzyme simulation lab. All right. Put your name on it, please. So then you will. Okay. So where do you submit it? So when you're done with all the graphs, okay. Let's turn. You can close the PowerPoint, and I need to save that. All right, so close the PowerPoint graphs, close all the software. This one I don't need to say. Okay, so now you I'm still in student view. So what you want to do is while you're still in your lab canvas, click on assignment. Okay, click on assignment. There should be a link for you to upload it. Okay, it says lab graphing exercise here, and then just click on it and click on say new. It's limited to 10. Okay, so yes, so choose the files where you've saved it. Okay, so I've saved all 3 files in the same directory. All right, so I want the PowerPoint graph as well as the two Excel file. Okay, so the Excel file with the protein XY scatter plot, and then the enzyme simulation lab, and then as well as the PP PowerPoint graph. Okay, estimation graph. Okay, so and then you click submit assignment, and then we're done. Okay, so well, thank you very much. And so if you want to watch the video to recap how to do it, that's good. And if you missed the lab last week, you have to watch this video to learn how to do it yourself. Okay.